Wow, thank you. So I have a lot to get through, so I'm just going to jump right in. Apparently I won't. The technology, it is hard. Here we go. Introduction. You already know my name. You already know I work for Canonical. My job title at Canonical has actually changed. I am now the tech lead for the QA team. That's kind of boring. The interesting thing, though, is that I spend an awful lot of time looking at regressions. To be honest, it can get a little bit depressing. I spend all my time looking at things that are broken. But what that does give me is it gives me perhaps a somewhat unique insight into things that break often. And it allows me to try and categorize things that break often versus things that don't break so often. So I won't say I have a unique perspective, but I have perhaps a slightly unusual one. This talk is born out of frustration, mine and other people's. I feel like when I was doing my degree and in the kind of formative years of my career, I was sold this vision that with automated testing, we could get to a point where we have a product, we have an extensive suite of tests, we can run the tests, and if the tests all pass, we can release the product and go home and sleep soundly at night. I've worked on a number of projects at Canonical. I've worked on a number of projects at other companies, including companies that define their software as being mission critical, including companies with multiple £1 million fines if it doesn't work properly, and I have never seen this. I feel like either this isn't achievable or we're not doing something right. That is my frustration. In particular, at Canonical, I have a high level of regard for the engineers that we employ. We do our very best to employ good engineers. If we can't do this successfully at Canonical, what the hell's going wrong? This talk is also born out of my dissatisfaction with some of the conversations that are happening in our industry right now around software testing and around QA. In particular, it's born out of my dissatisfaction with the conversation around unit tests. I feel like, don't get me wrong, unit tests are a great idea. They are wonderful. They're also a, 20, 30-year-old idea. And I feel like we haven't had a great idea since. Instead, we've been trying to take the unit test model and apply it to places where perhaps it doesn't fit so naturally. The old adage about to the man with a hammer, every problem looks like a nail, I think applies in this case. One of my personal bugs is that at conferences like this, there's always one or two talks about testing. That's wonderful. But very few of the talks discuss the fact that testing really is about code architecture. The two topics are so tightly bound. What normally happens is you'll come along to a talk about unit testing, they'll show you a unit test framework, they'll show you how to write some tests. You'll leave the lecture theater enthused and you'll go back to your own code base and you will cry into your keyboard. Because those simple examples that were on the slide, that world of promise and hope, no longer applies to your code because your code is real, right? It's complex, it has state, it has nasty bits, it talks to a real database, all that stuff. So this talk is me trying to reframe the discussion around testing a little bit. Sadly, I have no solution, right? I'm not here to sell you a thing. If anyone wants to leave and go and see the Solaris talk right now, you can totally do that. I won't be offended. So this is not a silver bullet. I don't actually believe such a thing exists. What I'm going to do, instead of trying to sell you a solution, is to try and extract some knowledge from that high-level view that I have. Try and extract some knowledge from those thousands of regressions that stream through my inbox every single day. So I'm going to talk about three separate broad categories of regressions, of causes for regressions. I'm going to talk about the obvious one first, which is what I'm determining, or what I'm calling algorithmic correctness, which basically means you wrote some code, it doesn't do what you want it to do. This is what hopefully everyone here thinks of as a bug. In this case, maybe I need a better name. Feel free to suggest one at some point. But in this case, an algorithm is, a piece of code, right? Here is some code. It the author intended it to do something. Perhaps it works properly, perhaps it doesn't. I may, in fact, have deliberately inserted bugs into some of these slides to see who amongst you can catch them. But anyway, you know, error handling, like that's also an algorithm. You have some process that you want to have happen. You wrote some code, and maybe it works, maybe it doesn't.
You put errors in all of them, right?
Maybe. That would be telling. So those of you who have done even rudimentary amounts of unit testing can look at this code, and already you can see how you would write the tests, right? It would look something like this. And obviously, you'd probably want more tests as well. And this is where many talks about unit testing stop, and this is what annoys me, right? These code examples are easy to test. Why are they easy to test, though? What makes this code simple and your code, or you know, my code, I don't want to make it sound like I'm dissing your skills. What makes this easy and like real code difficult?
It's self-contained.
It is self-contained. Yes. Who said no state? I want to hug you. Yes. Yeah, later. There is no state, right? It is. I love it when the audience predicts the next slide. It's just the most perfect moment. I am convinced, the more I look at code and the more I look at unit test suites, that statefulness is the enemy of unit testing, right? If you have code that manipulates state, all of a sudden in your unit tests, because you need to test things in isolation, you start mocking things, you start stubbing things. It leads down a world of hurt. Yes, don't use mocks or stubs. Because this is only a 25-minute talk, I have to kind of hand wave and move on a wee bit here. If you want to learn more about how to write a code base that minimizes the parts of the code base that contain stateful code, there's a whole lot of really good talks out there. One of them is from PyCon US 2013, I think, by Gary Bernhardt, called Boundaries. You should go watch it. If you're watching this on the internet, you should like pause this video and, you know. However, I think this is a mostly solved problem. I'm not saying that people get it right all the time. Most people don't get it right in my experience, but we're already having the discussions around how to solve this problem. I think the tools are already in place. We're starting to understand the kind of patterns in the code that are required in order to work around this. Also, in my experience, this actually doesn't cause that many shipped regressions. Right? Most developers that I work with are good enough about writing tests and doing the upfront work that this really isn't such a problem. So let's move on. Here's another category. What I mean by API compatibility here is a kind of broad category, which means you have two pieces of code, you want them to talk to each other, and that communication is broken somehow. And I'm going to split it into internal APIs and external APIs. Internal meaning internal to your code base, right? The thing that you control. So a incredibly silly but very simple example is something like this. You might have two functions. You want function A to call function B. And so there's a contract here, right? Function B has to accept the arguments that function A is providing. There's also some contract around the return value. Both functions have to cooperate in order to produce code that doesn't break. That really was my childhood nickname as well. It's like monkey proportioned, you know. If we change one of these, then obviously this is broken, right? This is a silly example because I have the two functions on the same slide. Of course, you can see that when you change function B, you know, function A is going to break. But these may be in different files. Right? They might be in completely opposite parts of the code base. And one of the problems I see, particularly in Python projects, is that Python gives us a huge amount of power around how we name and organize our code. There is no enforced privacy in Python. Right? We're all consenting adults and all that. What this means, though, is that if you're not careful around delineating the bits of your code base that are intended to be private and will likely change often, and the bits of your code base that are intended to be used elsewhere, you can run into this problem where it's incredibly hard while you're hacking on your code base to figure out how careful you have to be when you're modifying things. So there's a few things we can do to fix this. One of them is we can adopt a naming convention, right? We can try and name things so that we can tell just by looking at a function whether it's part of our public API, if you're shipping a library, your internal API, or your private code. I will very quickly show the naming convention that we've adopted in Autopilot, which is the thing I spoke about last year. Autopilot is a library as well as a tool, so we have said for anything that's public, we don't do underscores anywhere in the name. This is probably what everyone's doing already by default. So right now, as a hacker on Autopilot, if I want to change this class, just by looking at the class name and the module name, I know that I have to be ultra careful when I touch this class. If I change things, I will break the users that rely on us not to break. What I'm calling internal APIs are things where they're used elsewhere in the Autopilot code base, right? They're written to be reusable, but we don't expect our end users to use them. So when I look at this, I'm thinking, OK, I have to do a grep through the code base, find everywhere where this is used, make sure that if I'm making incompatible changes, that I'm fixing my users as well. And then finally, we have private code. This is stuff that's required just for the one module, just for the one file. I can change this, and I know that the scope of the impact of my changes is relatively well contained. What this boils down to is module design, right? I'm still talking inside your code base. So when you write your code base, you might think that the only thing that matters is the API that you ship. What I'm suggesting is that you also need to care about the other parts, the things that you use internally. Because otherwise, sooner or later, either you or someone else who contributes to your code will make a mistake. You will release a regression, and that will hurt. There are some interesting thoughts on whether we can do this automatically, whether we can detect API incompatibilities. I'll put my slides online, but this is a link to a topic in the Python Ideas mailing list from August, I think, sometime, where they're talking about the possibility of using Python function annotations as a kind of static type checker, which would help resolve some of these things.
The guy wrote things to do that about 5 years back.
Cool. Does it work? Something may exist that may or may not work. We should look into that. So this is, in my experience anyway, this is really a higher source of regressions than people making mistakes in their code. We need to fix it more than we need to fix making mistakes in your code. Now we get to the last category, and this is the big one. It's still API compatibility, but this is now between your code base and something that someone else wrote. And we all know that things that other people wrote are infinitely worse than things that you wrote. Somehow that applies to everyone. And when I say API, I don't just mean Python modules, right? I mean any external data source. So this includes, you're reading some config file from disk. Maybe the person who wrote that config file has changed the format, and you're now broken. Heaven help you if you're reading something from a web service, because they seem to change all the time. And that makes my life a living hell. There's all sorts of things here, right? Even the Python standard library makes incompatible changes from time to time. I'm sure they don't mean to, but it happens, and you have to deal with it. Each of these carries a different risk. The level of risk will be different in your project as it will from my project. The level of risk that you're willing to take on will be different in your project than it is in my project. But by looking at these and trying to think about them as a source of possible problems in the future, we can take steps as we're building our code to hopefully not run into these problems. There are a few things you can do to protect yourself. The first, and one of the most effective, is by isolating the interaction with the third-party component. If you are dealing with a particular third-party API, make sure that all the calls to that API are within one module so that you can run sanity checks in one place. If you ever need to change things, you can change them in one place and have that be effective throughout your code base. You can protect yourself with build time tests, right? If you are relying on a particular behavior from a third-party API, write a test suite that makes sure that that behavior is as you expect it to be. In Autopilot, we have tests that verify that test tools does what we expect it to, so that when we release Autopilot, we know if Robert Collins has broken us or not. It hasn't happened yet, but we'd be kind of stupid not to, right? There is a small note here, though, which is that if you are shipping in a Linux distribution, this is actually a lot harder, because we might release Autopilot with a version 1 of test tools, and then a new version of test tools might fly in and perhaps break us. And so the build time tests don't protect us in that case. You can also protect yourself with runtime tests. Build time tests only work when the endpoint is known about and doesn't change. I've written apps that talk to Jenkins services. And the end user supplies the URL of the Jenkins server. This is a problem because different Jenkins servers have subtly different data being returned from their web APIs. So what you can do is, before you accept the Jenkins server endpoint, you can run a suite of tests over that endpoint and make sure that the data that you get back is what you expect. There's no hidden surprises there. They're not running some funky version of their web API from 10 years ago. It takes maybe 10 seconds to run the test, but if it means that your user isn't surprised while using your application, and surprised in a bad way, it can work. It can be a good idea. This is, in my view, the highest source of bugs. Right? In the stream of Ubuntu bugs that I see going through my mailbox, I would hate to put a number on it, but I'm guessing 3/4-ish, maybe. When we track them down, they're caused by incompatibilities between libraries, between packages.
So we should stop writing libraries?
Yeah, we'll just bundle everything together. That is perhaps a solution. I was being sarcastic, but I can see from your face you're really not. We'll talk about it later. The final thing I want to mention is frameworks. So the difference in my mind between an API or a library on the one hand and a framework is a framework really tries to make it very easy to go from nothing to fully formed, writing as little code as possible. Another way of saying that is they try and do everything for you, which is great, right? It's wonderful. I can go from nothing to a massive web app with Django in like 30 minutes. The problem is that the flip side of that is they impose themselves on you. They require you, in many cases, to integrate your application code with the framework. And sometimes they do that in such a way that makes it very hard to test. Frameworks are getting better. A really interesting example is to go and build something with pylons and then build something with pyramid to see that they have made design changes from one framework to the other that make it much, much easier to test your application code and to have it separate from the framework. In all of this, there are some patterns that are emerging for me. My inbox is chaos. It is thousands of bugs streaming through every single day. And what I'm starting to see is that, as far as I'm concerned, we've mostly solved or are on our way to solving the unit test problem. That may or may not be a controversial statement. What I think we need to start doing is talking about the other things, right? Is talking about compatibility within an API, talking about compatibility between APIs. How can we get it so that, I'm sorry, Robert, when test tools, 1.3 is released and it breaks Autopilot, how can we get it so that I know about it before it ends up in the distribution or on the package index? So, I have nothing else for you. I am more than happy to answer questions, though, and if you don't want to talk to me in person today, you can always email me or tweet at me or one of those things. Thank you.
Yeah, hello. You briefly mentioned that you don't recommend using mocks or stubs. Can you elaborate on that a little bit more, please?
Sure. So the problem, if you have two pieces of code and one has to talk to the other in a kind of dependent way, you want to test piece A in isolation. So what you do is you mock out piece B, or you patch piece B so that it, instead of talking to the real thing, it's talking to your mock. So you write your unit test and everything is happy. But then what happens is piece B, the actual production code, changes, but your patch doesn't, because it's very hard to synchronize between the actual code and the patch that you've created. There are some things you can do, like in the mock library now, there's support for this spec keyword. But even then, it's very, very easy to end up in a situation where you have what I call a testing tautology, which basically means you're testing against your patch. You're not testing for the behavior that you actually want. So you can end up in a place where your tests all pass, but your thing is horribly broken when you go to deploy it.
Like the Code Wars worm last night.
Right, like the Code Wars worm last night. That had tests, did it?
Yeah.
Ah, I didn't know you could do tests in Perl.
But there's this thing where you run your tests against your old version of the code.
Right.
Or you run the new version of the old test. Or both.
Yes. I don't think that's a question, though.
Do you think it would help? Obviously, all I was going to say.
So the question is, just to rephrase it for the audio, there's this idea that you can run your new tests against the old code or the old tests against the new code in order to verify that the behavior in the new code hasn't changed. And the question is, do I think that can help? I guess the immediate problem that springs to mind is sometimes you want the behavior to change. So then you have this thing where you have failing tests, but I guess you can mitigate that. Depending on how you write your tests, it can make refactoring things tricky because names might have changed, they might have been deleted or moved around. I certainly think there's a case for running an integration test suite where you're testing, from the public point of a module, you're testing the public API and verifying that the low-level behavior has not changed. But I don't know anyone who's doing that. And I suspect that if you were to try and do that, you would find that some of the tooling perhaps was missing. It would be an interesting experiment to try. You should do it. And then tell us next year how it went.
Go and have an OpenStack. We do it.
You're going to pay me to do that? I think I just got a job offer. Wow, this is the best conference ever.
Any
Anyone
other
else?
questions? We still have plenty of time for questions, so don't be shy.
I wasn't fast, I was efficient.
Just in terms of educating new people, do we need to change our approach to teaching how to minimize state? Because almost all introductory Python material is mutability is never really a concern. It's just or is that a fundamental problem with the language design?
I don't think it's a problem with the language design. I do think it is a problem with education. I have not seen, bachelor level computer science education that isn't heavily kind of 10 years ago OO centric, and certainly doesn't talk about code design in this way. The more I write software, the more I end up writing the vast majority of my code in a kind of almost functional paradigm, which is kind of weird at first when you're writing in Python. So yeah, we need to get people to start thinking about their code differently, to start thinking about where the state is and where the decisions are. So yes. Anyone else? Down the front?
I think the tricky part is like teaching the awareness that unit tests are good for a certain type of tests. Integration tests are good for a certain type of.
Right.
And I think if you never went down the rabbit hole of unit testing everything and then your application falls down on the integration side, you sort of never develop the awareness that, hey, maybe I need some functional integration tests for my suite as well. And I think the other tricky part is if you're doing it right, unit tests are usually fairly quick, whereas integration tests can be fairly slow.
Yes.
So you have this instant feedback from the unit test, but running all integration tests may take a long time. I've seen a lot of applications where people said, oh, you know, the unit tests are really quick, but we actually disabled the integration tests because they were so slow.
Yeah. And so one of the things, go and watch the boundaries talk, please. It's amazing. But one of the things you end up with is you actually end up with very little code to write integration tests for if you follow that pattern. And so that makes it faster. There is a video talk called "Integration Tests Are a Scam." And the kind of 10-second takeaway from that is if you don't write your code where you push all the state up the stack as far as possible, you end up having to write integration tests for code that has lots of different branches. And so the sheer magnitude of integration tests that you have to write to cover everything is huge. You just can't possibly do it. And the fact that you're not doing things in isolation means that you end up with multi-hour test runtimes, which no one has patience for. So yes, I honestly can't remember what your question was, but I think I've answered it in a roundabout way.
You were talking about testing third-party APIs, and to be honest, made me cringe. Thought like, oh, this is like a big thing to swallow. I can see the benefit of it, but maybe you want to elaborate a little bit more where you weigh it in terms of, like, for example, risk versus how much effort you have to spend on this stuff, or how do you determine, think of an application where you do a lot of mashup, lots of services around, you bring it together, and I don't want to test against Google Maps, Twitter, and everything out there.
Yeah. So it certainly depends on the individual application. The experience that I've had in Autopilot is we build heavily on top of test tools. Like test tools touches an awful lot of our code, which is good. So in that case, the risk is very high. So, it made sense for us to do it. I can also see, though, that if you are in a case where instead of just pulling on one external API, you're trying to wear 10 of them, 20 of them, that can be very hard. I also think there's a huge hole in the tooling and libraries out there to do that kind of testing. Right now, I'm using a unit test framework because that's kind of all that exists in order to write those tests. I would love it if someone in this room were to write a tool that made it easy to write that kind of test suite, because I think that would reduce the overhead of having to do it. I think, we should talk. Oh, really? So I actually have a demo project on my laptop. We'll talk later. The other thing is, I think, hopefully, over time, framework authors will make our lives easier. Right now, there's a whole lot of frameworks where you cannot test the external API without having to spin up the whole framework, which might require a running X session, it might require an internet connection, it might require all sorts of things that make it really hard to write, isolated, fast tests for. Maybe, it sounds like you have a particular project, and maybe sometime over the conference we can talk, and I'd be very interested in your use case. But yes, I agree, though, it is a hard pill to swallow. I guess the question is, would you rather do that, or would you rather carry the risk of releasing something and having Google or Twitter or whoever your third-party provider is break your app without you knowing necessarily? So I got no answer for you. Sorry.
But we still have time for one question or comment.
Just to quickly point out another great Gary Bernhardt video is the imperative shell functional call. That kind of leads on from boundaries.
Yes.
Which is, yeah, it's fantastic. It's really good. And my question is have you looked into something like cognitive simulation testing tools at all?
I have not. You should tell me about them.
I haven't.
Later.
I'm asking you. It's a question.
Has anyone?
It's a fascinating concept, but I haven't delved too far into it.
Cool. You should give a lightning talk.
Thanks. Cheers.
One final quick question or comment?
So should we then give up on testing and focus on reporting?
No.
No.
Would you like some more? Earlier in this year, I don't know, maybe some of you saw it, David Heinemeier Hansen wrote this impassioned blog article. I think the heading was like, TDD is dead, long live testing, or something like that. And reading it, I really felt his pain, right? And that was actually one of the kind of motivations for me to write this talk is I understand where he's coming from. His solution didn't sit well with me, right? His solution seemed to be, this isn't working for me, so I'm going to throw out the TDD part of it. I think testing is required, and I am enough of an optimist, or perhaps I'm just naive, but I really do think that utopian goal is achievable, right? I do think one day, probably when I'm 50 or so, I'll be hacking on a thing, and I'll just be able to run the tests and release it. But I think we're a long way there. I just think we have to work a bit harder and make better tools and maybe make better languages. But reporting is needed as well. It's not one or the other.
Great, thank you very much, Thomi, for this talk. And next time you're in this room, you might want to come closer to the front because it's really nice and cool here. So join us in giving Thomi an applause.
Thank you.
And you've got 10 minutes to cool off until the next talk in here by François Marie.